Before I begin on this topic, let's talk a little bit about some common sense. When someone like me warns you about a common error people make in doing math, then shouldn't you pay a lot of attention to that? The fact that it's a common error means by definition, many of you are going to make that error if you don't pay attention. And don't think you're immune from this. So let's be sensible about that. I've been teaching over 20 years, and I've graded tons of papers, and I know what kind of mistakes you're most likely to make. If you can avoid the common mistakes, there really are not that many other mistakes to make. And so you can gain a lot by paying attention to these common errors. All right, well, let's start off with the first common error. And this is my way of introducing, or at least reintroducing, the distributive law. Because this mistake, distribution, is the one that is the most common on the first test I give in this course. And so anyway, let's have a look. Suppose you were looking at 7 minus 4 times x minus 3. All right. Well, first of all, what do we do first? Do we subtract 7 minus 4? Or do we multiply 4 times x minus 3? Well, think about the order of operations. Order of operations says we multiply before we subtract. So we've got to multiply 4 through this parentheses. And that's a distributive law. I know you've all seen this before, but I want to make a big deal of it because students typically, I don't think they practice this enough before this first test. And because they think, well, I can do all these problems, I've done this before. And by not practicing, they're not catching the common error of screwing up the distribution. So when you distribute, we're going to multiply negative 4. Let's think of it as negative 4 times x and negative 4 times negative 3. And so that will give us 7 minus 4x. And then minus 4 times minus 3 is, of course, plus 12. The negatives cancel. And then we can combine terms and get 19 minus 4x. So anyway, it's very, very common. I would say about half students on the first test we'll screw this up right here. They'll get a minus sign here, or they'll get a 3 here with a plus or a minus. But they'll mess up the distribution. And why? It's because they're not practicing those problems. They think they can do them. And yes, they can do them, except they can't do them accurately because they're not practicing and catching those errors. So, very common error. Always pay very close attention to distribution. All right, so I'm going to erase the board and give you an interesting problem. This problem is probably longer and more involved than you were accustomed to in your first algebra course. Let's read through it. We're going to solve for x. 8 minus 2, bracket, 3 minus 4, parentheses, x plus 1, close parentheses, close bracket, equals 5 parentheses, 5 times, parentheses, 2x minus 3, minus 2 times, parentheses, 1 minus x. Okay, the parentheses, I know you've seen before, brackets work the same as parentheses. In fact, it's part of what we call a grouping symbol. So there are four grouping symbols I can think of off the top of my head. They are the parentheses, the bracket, the braces, and then the division line. So we normally use parentheses most of the time, but when we need to encase parentheses in a larger parentheses, we typically go to brackets. So brackets go around or outside of parentheses. And if it gets bigger yet still, then we use braces. And so if we had to multiply all this by something, we would probably put braces around it. So they all work exactly the same. They're all grouping symbols. In other words, they group everything inside as one entity. And they all work like parentheses. Now the division line is a little different, and in the sense that it also is an operation. And so if you had x minus 3 divided by 2, then this is the same as parentheses x minus 3 divided by 2. And so it's not only means to divide, it also separates numerator and denominator. So it groups the numerator as one entity. That's why I wrote it as parentheses here. So it's also a grouping symbol as well. Okay, well, let me erase these, and then we'll start solving this problem. So what do we do first here? Usually the best policy in solving these more complicated problems, where there's brackets and maybe braces, is to work from the inside out. Now it's not a hard fast rule, but it's usually you'll get better results doing that way. There's less chance of making errors. And so my strategy here is to remove the inside parentheses, simplify this, and then remove the brackets. And along the way we have some distributions to do. And so now not a lot of students, but maybe a fourth of students facing this problem on a test will go 8 minus 2 first. They've forgotten the order of operations. Remember, we multiply before we subtract. So I can't subtract anything from 8 until I resolve all this mess here. All right, so let's go about that. So my first distribution is minus 4 times x plus 1. And we'll do the same over here. I'll multiply the 5 through here and the negative 2 through here. And so those little arrows, that's that's optional. I just like to illustrate the distributive process so that it really becomes ingrained in you. All right, so this is going to be 8 minus 2 bracket 3 minus, so I have minus 4x, and then negative 4 times positive 1 is negative 4, equals 5 times 2x is 10x, 5 times negative 3 minus 15, negative 2, and negative 2 times negative x is going to be plus 2x, isn't it? Now, I like to simplify inside my parentheses before I remove them. And that really does follow the order of operations. You want to simplify everything inside the parentheses first. That's your first step in the traditional order of operations. So this will be on the left side, it'll be 8 minus 2 bracket 3 minus 4. Those will combine, so I get minus 1 minus 4x. Close bracket equals. And on the right, we can combine a few terms. 10x and 2x is 12x. And then minus 15 minus 2 is minus 17. Now it's time to remove the bracket. Again, it works exactly like parentheses. And I have to distribute minus 2 times minus 1, minus 2 times minus 4x. So that gives me 8 plus 2. Negatives are canceling. And what's this? This will be plus 8x. Equals 12x minus 17. And we can do a little more simplifying on the left. I'll add the 8 and 2 together. They'll combine. 10 plus 8x equals to 12x minus 17. Well, I haven't skipped any steps, and as you get better, you skip steps at your own peril, and certainly I do when no one's watching. But I'm going to show all the steps generally, and I think that's a good idea. Until you get really good at this, is to don't skip steps. Take that extra couple seconds to write that extra step, and you'll make fewer mistakes, and you'll just do better. Well, one of my limitations to my little studio set up here in my house, which I'm broadcasting from, this is a spare bedroom, is that my board is only 3 feet by 4 feet, and I've run out of room, so I'm going to have to erase this work, regretfully, and then finish the problem. So let me do some erasing here. So here's where we left off. 10 plus 8x equals 12x minus 17. And now it's like any other problem. I'm going to, any other linear problem always ends up at some point with no more than 4 terms once you've done all the simplifying you can do. Here I'm going to subtract 8x from both sides. So, like I mentioned in the last video, this process of solving is an undoing process. And we also undo things by doing opposites. 8x is added here, so to undo it I have to do the opposite. I have to subtract. That cancels these, leaving just the 10. 10 equals to 4x minus 17. And then let's isolate the x by getting rid of the negative 17, and the opposite of minus 17 is plus 17. So I add 17 to both sides. 27 equals to 4x. And now what do? We need to divide by 4 because 4 is multiplying x. We don't subtract 4 from 4x. They're in like terms. But 4 multiplies x. The opposite of multiplication is division. So divide by 4. And the 4's cancel, leaving x equals to 27/4. There we go. So the problem is finished. Although I haven't checked it. This one actually would be pretty easy to check on a calculator because 27/4 is 6.75 exactly. So you can plug 6.75 in here in the calculator and see that both sides equal. It's a little more work to plug the actual fraction in and work it out, and that's okay too. But there we have the answer. Okay. One other thing I want to point out though is that the answer is not 27/4. The answer is not even 27/4 equals x. Well, it kind of is, but really the answer is x equals 27/4. So I think that's best communicated this way. If you just write 27/4, it's like a fragment sentence. It's like you're just kind of grunting the answer to me. Well, what's 27/4? Well, x equals 27/4. So write x equals 27/4. This is a mathematical sentence. You could put, I suppose, 27/4 equals to x, but that's kind of like, talking like Yoda in Star Wars. 27/4 is x. Okay. So the one thing I don't want you to do is to leave it unfinished. That is unfinished. And so finish the problem, spend an extra 2 seconds, write the answer, and then you're done.